Okay, so I'm going to be going over surface area and volume of pyramids, cones, and spheres right now. So last week we dealt with prisms and cylinders. Now we're going to move on to pyramids and cones. So here's some examples of pyramids. So we have a square pyramid, a triangular pyramid, and a hexagonal pyramid here for some good visuals. It's important to note that a pyramid is a three-dimensional figure with all the faces except one intersecting at a single point. And you name a pyramid by the shape of the base. So notice in our square pyramid here that we have a square on the bottom, and then all our sides here become triangles that meet at one certain point. A triangular pyramid will have the base being a pyramid and then three sides that are pyramids that meet again at a point. Our hexagonal pyramid, we have a hexagon for the base, and then now we have 6 triangles that all meet at a point. And that point is actually called the apex, so that vocab word might appear, the apex, meaning the top. So the first one we're going to take a look at is working with square pyramids. So we have the surface area formula, which is surface area equals side squared plus 2SL, where S is going to be the side length and L is the slant height. Volume, and it didn't come through on here, the volume formula is going to be 1/3 base times height, where the big B means base area and height is going to be the height of the pyramid. So two things to point out right here is slant height and height. Those are both different. The slant height, and actually they're going to show you right down here, the slant height is from the apex going down the side. So like if you were sliding down a pyramid, so that's your slant height. So if you were looking at a pyramid and you were up at the top and you were to slide down it, you're going to come right down the middle. That's your slant height. Whereas the height of the pyramid, that's from your apex directly down. So that would be like inside the pyramid. So if you were an Egyptian and you were sitting on top of a pyramid, you would be then falling directly down inside of it. That would be the height of the pyramid, where again the slant height would be on the side there. So it's very important to make sure we understand which one we're using. So I'm going to go through example 1. It says to find the surface area of this pyramid here. So using our formula for surface area, we have side squared plus 2SL. So side squared means to take the length of the side of the base. So 20 is going to be plugged in. So we have 20 squared plus 2 times 20 again times L, the slant height, which is 26. 20 squared is going to yield 400. 2 times 20 is 40, and then 40 times 26 will be 1040. Add those together, 1440 centimeters, and because we're dealing with area, we know our unit will be squared. Number 2 is to find the volume of this. So we're going to go back up to our formula here. We're going to use volume equals 1/3 the base times the height. So 1/3 times the base, which will be the base area, which will be 20 times 20, and height is 24. Did I do that right? I think I messed up on something. Hold on. So then 20 times 20. So our area on the bottom here is 400. Times that by the height, which is 24. And then dividing that by 3 gives us a volume of 3,200 centimeters cubed, because volume is always cubed. So example 1 and 2 is working with a pyramid. a square pyramid with a base of 20 by 20. The next 3D object that we're going to deal with is a cone. So thinking of like what an ice cream cone looks like. It's a solid three-dimensional object that has a circular base joined at a point by a curved side. The point is called the vertex. So looking right here, here's an example of a cone. We have a circular base, and then the sides all meet at this point right here. That's called the vertex. Our formula is going to be pi r squared plus pi rl, where r is our radius and L is our slant height. Again, the slant height. And then the volume of a cone, 1/3 pi r squared h, where r is the radius again and h is our height. So let's go through example 3 here. It says to find the surface area of this cone. So plugging in, we'll have 3.14 times our radius, which is 6, square that, plus 3.14 times 6 times 10, because we're choosing 10 to be the slant height. Again, notice how the slant height is like if you were sitting on top of a cone and you slid down. Doing our math out, 3.14 times 6 squared will be 36 times 3.14, or 113.4. And then 3.14 times 6 times 10 gives us 188.4. Add those together, 301.44 feet squared is our answer for our surface area. Going down to example 4, it asks us to find the volume of the cone. So formula 1/3 pi r squared h, plugging in 3.14 for pi, our radius is 6, square that, and then now multiplying by the height, which is 8. So this 8 stands for if you were at the top and you went directly inside of the cone, it would be 8. So then doing the math out, 1/3 times 3.14 times 6 times 6 times 8 gives us 301.4, does it? I think it does, unless I just copied that. 36 times 8 times 3.14 and then divided by 3. Yep, 301. I just realized that they have the same surface area and volume. That does not happen all the time, so that's interesting that I chose that. Remembering it's feet cubed because, again, we're dealing with volume. And then the last example we need to do is going through a sphere. So our formula for the surface area is going to be 4 pi r squared for our surface area. And then our volume will be 4/3 pi r cubed for our volume of a sphere. So looking at example 5 here, it says to find the surface area. So we'll just use our formula, 4 times 3.14 times our radius, which is 6. Square that, so 6 times 6 is 36, times 4 times 3.14 gives us a surface area of 452.16 centimeters squared. And then example 6, find the volume. So our formula, 4/3 times 3.14 times 6 cubed. So then doing that out, we want to do 6 times 6 times 6, because remember that means 6 cubed. Multiply that by 3.14, and then you can multiply that by 4 and divide by 3. So 904.32 centimeters cubed. So there we have it. There's our notes for finding surface area and volume of pyramids that come to a point, cones with a circular base coming to a point, and spheres that look like a giant ball. So any questions, let me know. Otherwise, hope that helps with the math that you need to do for this week. Thanks.